All right, the problem is asking, does advertising money increase sales? So this is a causal model. So we're going to go ahead and do a simple regression on this, not a correlation. Go to Analyze. Regression. Linear. Remember, it's part of the assumptions is that the data is linear. Okay, our DV is the number of sales, and we think it's the advertising that might be causing the sales. We're going to see what we got in statistics. We always get the descriptives, I always do. We really don't need part or partial correlations because there's only one IV, one DV, right? One predictor variable, one DV. So a lot of this stuff we don't need. We don't need collinearity, not at this stage of the game. So that looks good. Okay, we're going to go into plots. We still need to check on homoscedasticity. So we're going to go get a Z pred, that's going to be our X, our Z residuals, that's always our Y. We always want the histogram. Okay, we're going to use the Mahalanobis to tell us if there's any significant outliers. Okay, click continue. All right, I don't think we need anything in options, but let's just take a look. Yeah, we don't need anything in there. So I believe we're set. We're going to click OK, cross our fingers. Here's our SPSS output. So right off the bat, this tells us that there were 24 pairs of data. And here's the correlation between the amount of sales and the amount spent on advertising, and it's pretty darn high, right? 0.916. And this tells us that it is a significant relationship. Okay, it's less than 0.05. It's really less than 0.001, but okay. This tells us that this was a simple regression because there's only one model here, okay? If it was hierarchical or something otherwise, you would have a 1, a 2, etc., etc. But again, we'll get to that later. Here is your money box, your R squared box. That is very high. So in other words, about 84% of the variance in sales can be explained by how much was spent on advertising. So this is a very, very strong model. And then the ANOVA is testing against R squared being 0. So the null hypothesis in this ANOVA test is R squared equals 0. This says that there's a significant difference between 0, so you get to reject that null and say that the R squared is not 0. In fact, we already know what it is. It's almost 84%. And then here are your beta weights, which in a simple regression should be pretty much the same as a correlation, and it is. But this is very, very strong. Here's your unstandardized B weight. So if you want to use real units, in other words, dollars in advertised spending and number of sales units, you can go ahead and do that. And then lastly, we're going to go in there and check the results from the Mahalanobis tests. So we go to Mahal distance and we go to the maximum, 3.058. So we're going to have to look up what the maximum is on a Mahalanobis critical distance table or a Mahalanobis Excel spreadsheet. So we're going to go ahead and use the Excel to determine what the highest Mahalanobis critical distance can be. So please hold. Okay, here's the worksheet. So alpha, the critical alpha we always use is 0.05. N is the sample size. Remember there were 24. K is the number of IVs. So there's one IV. And then we just hit enter. So if we have any Mahalanobis distances over 9.4, we're in trouble. But we didn't. So according to our output, again, our biggest Mahalanobis was 3 point something. So we're good to go. And that's about it. Since we got the histogram here, let's take a look at it. Looks pretty almost normal. It's not perfect again. And this again will tell us, this one right here will tell us about the Mahalanobis as well. So here's the 0 line. So you pretend there's a horizontal line. It cuts this right in half. There should be roughly the same amount of dots on top as there is on bottom. Again, it's not perfect, but it's close enough to go. And I hope that helps. That's how you do a simple regression model in SPSS. MGZ and the Mighty Bongster out.